In the part 1, we learned what are limits, and then we just kind of moved on to how do we read the limits from any kind of given graphs. In that, we saw a lot of different kind of graph, but today's class is not going to be on graphs. Now, we're going to see what to do if we don't have any pictures, and how do we solve these limits algebraically, or in other words, when you have equations instead of pictures. It's a pretty easy thing because the first instinct whenever you see a limit is just like plug it in, and a lot of the times the questions are not that hard. So the first instinct you should get is just like plug in your limit and test what happens after. So let's just say in this question, if I plug in my limit, we all know if I plug in 2, it's gonna be 2 times 3 plus 5, which indeed turns out to be 5 plus 5, and your final answer is 10. Pretty simple. And there could be like a variety of algebraic expressions. There could be like reciprocal functions. There could be quadratic functions like this one, the second question. But the idea is still the same. Just plug in your value and see what's going on. So let's just say in this kind of question, I plug in -1, and I get -1 squared plus 4 times -1 plus 6. And if I further simplify, I get -1 squared is -1 multiplied by -1, which is 1. And then 4 multiplied by -1 is -4. And then plus 6. In other words, I'm getting -4 plus 6 will give you 2, and 2 plus 1 will give you 3. So in other words, oh wait, let me just see. Yeah, you'll get a positive 3 out of this question. Pretty simple. And the other kind can be this one. You just plug in 2. It's going to be 2 plus 7 over 2 plus 1. And now the final answer from this one is 7 plus 2 is 9. And 2 plus 1 is 3. If you further simplify, you get 3 ones are 3 threes are. And then 3 is your final answer. But unfortunately, life ain't that easy. Because if you get these kind of questions, then these are the same questions a high school student can also do. Or like an early student in grade 9 or grade 8, he could also solve these ones. So, to make your life a bit harder, what happens when we do the same thing? Like we plug in directly. Let's try. So if I plug in 2 here, I get 2 squared minus 4 over 2 minus 2. Now if I look closely, 2 squared is 4, and 4 minus 4 over 2 minus 2. This, in short, leads me to 0 over 0. Now, half of you might think 0 over 0, oh wait, it's 0, right? No. Unfortunately, 0 over 0 is not 0. It's an indeterminate form. Or in other words, you just say, bro, I don't know what the limits are. So, should we just like, I don't know, or like indeterminate form? No. We have to change the expression so we can have some sort of value from the limit. And how do we do so? For that, if we look at the question again, there's this thing called factoring method, and factoring is nothing new to you guys. We all have learned in our early days how to factor, but just to be sure that we know that, in this kind of question, if I plug in, like before I plug in, I kind of try to factor x squared minus 4 over x minus 2. Now, I know I cannot take out, subtract, delete, or do anything with x minus 2. So I just leave it like that. But x squared minus 4, if I look closely, this x squared minus 4 is following this property, which is a squared minus b squared is the same as a plus b, a minus b, which was an identity we all learned in our schools. And if I follow this identity, this x squared minus 4 can be changed into this by x squared minus 2 squared. And in other words, this turns out to be x plus 2 and x minus 2. And since this x squared minus 4 is the same as x plus 2 and x minus 2, I write it here. I say x plus 2, x minus 2. And this is all over x minus 2. Now, if you guys carefully look, there's one thing which is same on the top and same on the bottom. And that thing is this x minus 2. So I simply cancel x minus 2 and x minus 2. In the end, after all the cancellation, I'm left with x plus 2. And we all know that this x plus 2 and this whole expression on top in the purple, they're both the same things. So now I could just simply say that my limit x approaches 2. Now instead of writing the question expression, I write my simplified version, which is x plus 2. And now what happens? I plug it again. And now I put 2 plus 2, which is 4. And boom. From indeterminate form, 0 over 0, we went to this. But in some of the school curriculums or even in some universities, they say it's really important for you to show this step, which is just basically telling them that it's an indeterminate form. And after you show the indeterminate form, you just start to do the factoring method. Or sometimes it's specified in the question that you don't even have to show this and just apply the factoring method. Let's see one more thing. The ideology is the same as the above. I'll take this really quick. And if I look at this question, I say, I plug in 3 first of all. 3 squared minus 9. 3 minus 3. Eventually when I see this, I automatically know it's going to be 0 over 0. So I write 0 over 0. This is an indeterminate form. Now what? Now we start simplifying the expression. The expression said x squared minus 9 over x minus 3. I look at x minus 3, I say I cannot do anything with it. But for x squared minus 9, it's following the same identity. So this, indeed, x squared minus 9 would turn out to be x plus 3 multiplied by x minus 3. And now you could just write this instead of x squared minus 9. X plus 3, x minus 3. If you want to know how I got this x plus 3, x minus 3, you could see this other question which I did. And then you divide it by x minus 3. Now you notice something same on the top and the bottom, which is x minus 3. So you just simply cancel it. And now you're left with x plus 3. And again mentioning this x plus 3, the simplified expression came from this original expression. So I can just write the limits again, but this time with my new expression. Limit x approaches 3, x plus 3. And now if I put 3 in there, I get 3 plus 3, which is 6. Another time, there could be more than one time you need to simplify, or there are more simplification techniques. You need to use high school algebra for that. Look at this question. Just to save some time, I'm telling you this is an indeterminate form if you plug it in directly. So you gotta simplify first. And how would you simplify this? The x plus 2 cannot be simplified further. But if you closely look at this, x squared plus 5x plus 6, it's a quadratic example. We can solve it by middle term breaking, applying the quadratic formula, or by the sum of squares. 3 methods. But right now, just to keep it simple, I'm going to apply the quadratic formula. In case if anybody doesn't know it, I'm going to take it slow in this example. But for the next ones, I'm going to be really quick. So this question, we see we have a quadratic expression. We quickly remind ourselves how to solve this. We say two numbers that when you multiply should be the same as a multiplied by c. In the other case, the coefficient of x squared and the constant multiplied. So 6 multiplied by 1 is 6. And when you add them, they should be the same as the middle coefficient, or the coefficient of x, which is 5. So let's think of two numbers like that. So if I do 6 times 1, I get 6. Now, if I do 6 plus 1, I get 7. And we low-key don't want to do that. So what should we do? We'd say on any other two numbers, which are not 6 and 1. So I just take maybe 3 and 2, because 3 times 2 is 6. And guess what? 3 plus 2 is also 5. Then boom, we found our number. So now, instead of this 5x, I write it in these two numbers. I say x squared. Instead of 5x, I broke it into two numbers, which is 3x plus 2x plus 6. Now, you do the grouping and take out your factors, which is x grouped out, and it's going to be x plus 3 inside. Then you take 2 out from the next one, it's going to be plus 2. And the only thing staying inside would be x and plus 3. The idea of knowing if you're on the right track, you see you find the two same brackets. That shows you you're on the right track. And once you do that, you write the bracket once, x plus 3, and then the leftover together. So x plus 2. And that's it. That's the simplification of the top. You can't go further bottom. So I say that this thing is the same as this thing on top. So I'm going to replace it with that. And now I start to notice, I see that x plus 3 times x plus 2 divided by x plus 2, I start to see something cancel, which is x plus 2. And if I do see this cancel, I just like write simply x plus 3. Now I apply my limits. X approaches to minus 2. And I write it here, minus 2 plus 3 gives me 1. That's it. I would highly encourage you guys to do this question on your own, because if I start to do it again like this, it's gonna take a bunch of time. But the idea is still the same. You simplify this, by using the same method looking at the previous question, and you'll eventually get the answers. But just to save time, if anybody needs help with like quadratic expressions, I would just want you to just leave it in the comments so I could like keep in mind to make a video on that one. Though there are a lot of resources online, but yeah, if you need my help on that one, just shoot me a mail. A lot of common mistake that people do is, first of all, don't consider that the answer is going to 0 over 0. Because a lot of the times, the question sometimes can be tricking you. Like you see a really big question, but then it's of 1 mark only. Because half of the time, the thing is people assume that they're sometimes like they're 0 over 0. So we always have to do the factoring. But if it's a 1 mark question, you already know that it's not going to be indeterminate. So be mindful when you're solving this. Keep simple steps in your head that plug in first. See if you're getting an answer. If you're getting an answer, you're good. But if you're not getting an answer, you're getting an indeterminate form. Then you do the simplification through factoring. I showed you the simple kind of factoring. And pretty much that's it for factoring. In the next class, I was planning to do questions like these. Because you see, these kind of questions, they cannot be factored out. They use another technique called, what was a better word? It's called, it's like conjugate. To use the concept of conjugate and square root. So that concept I'm planning to cover it in the next part of this video. And until then, if you have any problems, shoot me a mail, put it in the comment section. Please give it a like and share it among your friends. And have a good day. Thank you.